Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, paper 3-1 for May, June 2024 for questions 1 to 5. Question 1 is coming from binomial expansion. They are saying expand 3 plus x then into 1 minus 2x then to the power of a half in the ascending powers of x up to and including the term in x squared, simplifying your coefficients. Now, we are going to use the binomial expansion, and this is how it states. If we have a plus b, then to the power of n, and this n for this paper 3 can be a positive integer, a negative integer, it can be a fraction, like here we are given a fraction, okay? Now, we are going to have this a, you just put the power on this a, the n onto the a, and then b power 0, then divide by 0 factorial. So what is here as the power is the one that comes down here as the factorial. Then plus, now you be like you're differentiating a. So you drop this power here. So we shall have n, then a reduce this power by 1. As a reduces in the power, b picks that power. And then you divide by 1 factorial, then plus. Now drop this power here. So we shall have n into n minus 1. Now a, when you get n minus 1, then minus 1, it becomes n minus 2, and then b to the power of 2 out of 2 factorial. And when you add these powers of the terms, you get the n given to you, okay? So this is what we are going to use here. We have 1 minus 2x, then to the power of a half. So we shall have our a is now a 1, put that a half as the power, then negative 2x, please carry the negative with that term, okay? Then power 0 over 0 factorial, then plus, drop the half, then 1 power a half minus 1, that one will give you negative a half. So we shall have negative a half here, and then negative 2x here will be to the power of 1, then over 1 factorial. So they said up to the term in x squared, so that means I will continue and then drop this one down here, so it will give us a half, then into negative a half, then 1 here will be to the power of negative 3 over 2, because if you get negative a half minus 1, that is what you get, okay? And then negative 2x here, then to the power of 2. Then we shall put 2 factorial here. The rest is just to simplify. So I'll end on this one here because x is already to the power of 2. Of course, this one will be 1 because 1 power any number will be 1, and 0 power to any number will always be 0. 0 factorial, will always be 1. And then 0 factorial is 1 because there is only one way of arranging an empty set. Then here we shall have a half times negative 2. That one will give us negative 1. So we shall have minus x, and then here we shall have here we shall get negative 1 over 4, then times this one here will be a 4. That means we get a negative 1, okay? Negative 1. And then down here we have a 2, so it will be negative a half. That's what we are getting here. So the coefficient of x squared here is going to be negative a half of x squared. Remember, when you square, everything there is squared, okay? Then next, we are supposed to expand. It is 3 plus x into the 1 minus 2x, then to the power of a half. That means here we are having 3 plus x, then times what we have gotten, 1 minus x, then minus a half of x squared. So 3 times everything here, that one will give us 3 minus 3x, then minus 3 over 2 of x squared, then x times everything here. This one will give us plus x, and then minus x squared. Of course, this one I will leave it when x multiplies with it because it will be x power 3. And yet we want only those terms that end. It has to end in x squared, okay? So you ignore the higher powers. So meaning we shall have 3. Now this is minus 3 plus 1. You get minus 2, okay? So that means here we shall have minus 2 of x, and then minus 3 over 2 minus 1. This will be negative 3 minus 2, that is minus 5 over 2. So that means the coefficient of x squared is going to be minus 5 over 2 of x squared. So this is going to be our answer. Question 2 is coming from logarithms. We have solve the equation natural log of x minus 5, which is equal to 7, then minus natural log of x. Give your answer correct to 2 decimal places. Now, using the rules of logarithms, I can actually bring the two logarithms onto one side. So natural log of x minus 5, and then I will have plus natural log of x. Then I leave the 7 here. Okay, then here using the rules of logarithms, I'm going to multiply the powers because this is addition. So it will be natural log of x minus 5, then times the natural log of x. Okay, then this one is equal to 7. Now we have a rule in logarithms that log of a power b then is equal to c. This means that a power c is equal to b. I always put these arrows. A power c is equal to b. Okay, remember logarithm is that power you are supposed to raise a number to, okay, to give a certain number. Now, natural log of x is the same as saying log base e of x. So meaning here I have log base e and then this other power here. So what I'm going to do, it is to say that x, when I multiply here, it will be x squared, then minus 5x, then it will be equal to e power 7. Because there is an e here, now power this, then it will be equal to what is there. Okay. Then after that, I can bring this one here, x squared minus 5x, then minus e to the power of 7, which is equal to 0. And this one is a constant. So this is a quadratic equation, and you can solve it using the quadratic formula because you cannot factorize this. We know you know how to use your calculator, okay? But please substitute, show the examiner that you have substituted into the quadratic formula. X is equal to minus b, okay, then plus or minus to the root of b squared minus 4a, then c, okay, like that. Then out of 2a, your a is a 1. Then from here you can write your answer. Okay, we are going to ignore the negative part because logarithm cannot be a negative. So when I put the negative value here, there is no number you're going to power with anything, and then it gives you a negative number. Okay, so we are going to, there is no positive number you're going to power with any number, and you come out with a negative. So that's why we are only going to pick the positive. So putting this in the calculator, what do we get? We shall have 5 here, then plus 5 plus the square root. Inside here we have 25, then plus 4, then e to the power of 7. Okay, because negative times a negative, it will be a positive. Then divide by 2 here. And then we get our answer as 35.7 to the rest of those figures. But they said we give our answer to 2 decimal places. So it will be 35.71. Okay, 35.71 to 2 decimal places. As simple as that. Next, question 3 is also coming from logarithms, but we are transforming the exponential functions into linear equations. So the variables x and y satisfy the equation a power y, which is equal to bx, where a and b are constants. The graph of y against natural log of x is the straight line passing through these points here, as shown in the diagram. Find the values of a and b. Give each answer correct to the nearest integer. Now, before you start such questions, always look at what they have put here on the axis. We have y here and then natural log of x. So meaning the coordinates that we are having here, this one is a natural log of x and this is a y. It is not, this one is not x. No, it is not x. It is not x. It is natural log of x. So always pay attention to what they put here. Okay? That is that. Now we can start. We have to reduce this one to logarithmic functions. So what we can do is to introduce logarithms on both sides. So natural log of ay, I'm introducing logarithms on both sides this way and then this way. Okay, so we shall have natural log of a power y, which is equal to the natural log of b of x. Okay, and we know that from logarithms, this one can come here. It's a rule in logarithms. So we shall have y, which is y times natural log of a, which is equal to, since this is a multiplication of the powers, this one comes from addition of 2 logarithms to the same base. You see that? Now take this natural log of a, this other side, we shall do it by division. So that means y is going to be equal to 1 over natural log of a. I can bring the natural log of x first, then plus natural log of b, also times 1 over natural log of what? Of a. So this one is in the format y, which is equal to m, then x plus c, because this is the general equation of a straight line. You see that? So in this case, therefore, 1 over natural log of a is the gradient, and then this is the y-intercept. But since we don't know the y-intercept when we look at the graph that is given, that means to find the value of a here, we shall just substitute using the values that are given. Okay. Now, our gradient is 1 over natural log of a. So you show how you find the gradient. Gradient is always equal to the change in the vertical axis divided by the change in the horizontal axis. So the gradient here, look at the values given. We have the change in y is therefore going to be 1.50 minus 1.00. So you get this minus this, then over this minus that. Okay. So we have divide by 1.31, then subtract 0.336. And then this one has to be equal to 1 over the natural log of a. Okay. 1 over the natural log of a. There is somewhere I say that now if we want to find the value of a, then we have to substitute in the equation. No, I meant for b, because for a we can get it using the gradient. Okay, pardon me there. Now, what do we get when we simplify this one here? 1.50 minus 1, then we divide by 1.31 minus 0.336. So it gives us 250 over 487. 250 over 487, which is equal to 1 over the natural log of a. That means when I cross multiply or I somersault, this simply implies that natural log of a is equal to 487 out of the 250. So then our a will be equal to e to the power of this whole thing over that. And remember, we are supposed to write our answer to the nearest integer. So what do we get? E power the whole of this. So now here we have e to the power of that. So shift, then natural log, then the e comes there. We have 487, then divide by 250. This one gives us 7 point whatever, but then to the nearest integer, a will be equal to 7. As simple as that. Then to get the value of b, I will just substitute. Okay, I'll just substitute. I'm going to get, first of all, we have our y. I'm going to use this one here. Okay, I'm going to make natural log of b the subject of the formula. So natural log of b is going to be equal to, I'm substituting here, okay, is going to be y natural log of a, then minus the natural log of what? Of x. So meaning natural log of b is going to be equal to, you get one coordinate that we can use, maybe 1.31 and 1.50, 1.31 and then 1.50. This is what I'm going to use. Remember, this is natural log of x and then this is y. So y is 1.50 and then natural log of a, natural log of a, do you see that it is this one here? So I'm going to use that exact one, not the not putting here that natural log of 7. Okay, I'm going to put times, this is 487 out of 250. You see that? Then minus the natural log of x is going to be 1.31. So for me to get b, okay, from here it is going to be e to the power of the whole of this, and you can put the whole of this on the calculator and you get the answer. So b is going to be e to the power of 1.50 times this 487 out of the 250, then minus the 1.31. The whole of this is a power of the e. So therefore, what is our b? Shift, then natural log, the e comes, and then we are going to have the whole of this there, 1.5 times 487 out of 250, then we can subtract 1.31, then we cross the brackets. So that one will give us a 5, okay? Because to the nearest integer, it has to be a 5. So b is equal to 5. Next, question 4 is coming from complex numbers. The complex number u is given by u, which is equal to -1, then minus I root of 3. Part A, express u in the form r cos of theta, then plus I sin theta, where r is greater than 0, and then theta is ranging from -pi to pi. Give the exact values of r and theta. Now, before you find the argument of any complex number, always first find the quadrant within which it lies, okay? Always do a sketch of the Gantt diagram to see where it lies. So the simple one is this. So we have the imaginary, the vertical axis is the imaginary, and then the the horizontal one is the real. So we have -1. -1 is here for the real, and then this is a -√3 for the imaginary. So maybe I can put it here as -√3. So meaning where they coincide, it can be here. So the complex number is here. Okay, that is our u. You see that? Now the argument of this u, remember, it must range from -180 to 180. So we go anti-clockwise if the argument is less than 180, if it is here. But if it goes beyond 180 degrees or beyond pi, we instead go clockwise. And here the angles are negative. Okay? So when we move this way, the angles are negative. When we move this way, the angles are positive. So the argument that we must look for is this one here. But I can just get this smaller one here. I can let it be, let's say, alpha. Okay, so that is that. Now I can say, I don't mind about this being a negative and this one a negative. I just want to get this acute angle. Okay, so I take these ones as positives. I just take them as lengths. Okay, just as lengths. Now, when I take them as lengths, so here I have a length of 1, and then here √3. You see that? So since this is the opposite to this angle and this is the adjacent, that means using SOHCAHTOA, I will be using TOA. That is tan, opposite and adjacent. So I have tan of alpha is going to be equal to the opposite, which is √3 over the adjacent. So meaning alpha is going to be equal to the arctan of √3, which is 60 degrees. That I can write as pi over 3, because the range given here for the theta is in radians. Okay, so meaning my theta is first of all going to be negative. Okay, because I'm moving this way. Then from here to here, it is 180. Okay, so I will just say 180. Forget about the negative. I've already captured it here. Okay, 180, then subtract this angle that you have gotten here. So that angle is pi over 3. You get that? So meaning this will be 3 pi minus 1, that is 2 pi. So it is going to be -2 pi over 3. That is the argument. Okay, now how about the r? R is the modulus. What is the length of this one here? Already this one here is a right angled triangle. You have something like this. So you have this as the y. This one has to be x squared plus y squared under the square root. You see that? So we are going to have r, which is equal to this u here, the modulus. So we shall have -1 squared, then plus the -√3 also squared. Now, when I square this one here, it will give me a 3, then plus the one that comes from here, that will be a 4, then √4, that one will give me a 2. So meaning u is going to be equal to, our r is 2, then inside here we shall put cosine of -2 pi over 3. We are substituting here and here, okay? Then plus I, then sine of -2 pi over 3. you can leave your answer like that, or you can write it like this. We know that cos of a negative angle is always equal to cos of that angle. Why? Because in the four quadrants, we know that cosine is positive in the first and fourth. Okay, so when you go negative, when you go clockwise, that is when the angles are negative. So you are going to fall into the fourth quadrant where cos is positive. So you are falling into the cos quadrant. That is why the cos of the negative angle gives the same value as for the positive. But we know that sine of the negative angle is equal to negative sine of that angle. Are we there? Why is it like that? It is because when you move again from here, 0 here, and then you are moving clockwise, it is negative. Now, you are falling into the cosine region. You see that? And in the fourth quadrant, sine is negative, sine is positive in the first quadrant and second quadrant. And then it is negative in the fourth quadrant and third quadrant. You see that? So, meaning if you move negative, you're going to fall into the region of this one here, where sine is negative. So that's why sine of a negative angle is equal to negative sine of that angle. So alternatively, I can write my u as 2 into cosine of 2 pi over 3, then minus I sine of 2 pi over 3. So whether you write your answer as the second one or as the first one, it is all the same. Okay, it can be this one here or this one here. Then the next one, they are saying the complex number v is given by this. Express the complex number v over u in the form. This one is the exponential form. Okay, exponential form. Now, we are going to use the rules of indices. It is known that e to the power of I theta, it is equal to cosine of theta, then plus I sine of theta. So meaning v is going to be equal to 5, then e power pi over 6 of I. Okay, because the theta, I want you to check what is here. It is the same and also here. So it is the same power that has to go here, the angle, the argument. Okay, so meaning that is what we are having there. How about u? U is therefore going to be 2. Then by using the first one, we are having here, this is the argument. So we are going to have e to the power of negative 2 pi over 3 of I. Okay, now when we find v over u, it is going to be 5 e to the power of pi over 6 of I, then divide by 2 e to the power of negative 2 pi over 3 of I. Now here we shall have our v over u, which is equal to 5 over 2. Using the rules of indices, this will be e, then to the power of pi over 6, then minus 2 pi over 3. All of these ones have got an I on them. Okay, now 1 over 6, this one is going to be a plus. So what is 1 over 6 then plus 2 over 3? Okay, I can just multiply this one by 2 such that they have the same what? Denominators. So I will have 1 over 6 then plus 4 over 6. So 1 plus 4, you get a 5. So that means we shall have 5 here, 5 over 2, then into e to the power of 5 pi over 6 of I. So that is going to be our expression. So the new r is this 5 over 2, and then the new theta is this 5 pi over 6. So that is that. Question 5. The equation of the curve is y is equal to e to the power of sine x divided by cos squared of x for x ranging from 0 to 2 pi. Find y dx and hence find the x coordinates of the stationary points. Of course, you know that for stationary points, dy dx is equal to 0. So here we are going to use the quotient rule. Okay, and the quotient rule states that if we are differentiating, if it is even given in the list of formulae, So if you have your y, which is equal to v, which is a function of x, then over u is also a function of x. That means that dy dx is going to be equal to v, then du dx, minus u, then dv dx, then divide by v squared. So our u here is going to be equal to, and you also know we have here the exponential function. When we differentiate an exponential function, e to the power of f of x, what we do here, just get the power of that e, you differentiate it, then after differentiating, you multiply by this exponential, okay? So, meaning our dy dx is going to be equal to, what is our v? It is cos squared x, then times the derivative of this e to the power of sine x, then minus our u is e power sine x, then times the derivative of cos squared x. This one I'm just going to write it like this, cos of x then squared. It is the same thing as this, okay? And then we can divide by the cos squared of x. We also square it, but then after we equate this one to 0, because for stationary points dy dx is equal to 0. Now when we differentiate this one here, we get a cosine of x. So we are going to have cos squared x, that is here, okay? Then times, here we get cos x. When you differentiate sine x, you get cos x. Then now times the e to the power of the sine x, what I've told you here, okay? Next, minus, this one is going to be e to the power of sine x, then times, when you are differentiating this one, first drop the power, because here there is chain rule. Drop this power, we shall have 2, then cosine of x, reduce the power by 1. So 2 minus 1, of course you get 1, okay? Then after that, you go inside and you also differentiate. So when we differentiate cosine of x, we get a negative sine of x. So we say times negative sine of x. This is cos power 4 of x. Now, here cosine, we have e, there is cosine of x which is common. I can see it here and I can also see it here. You see, I also have e to the power of sine x, it is common here and also here. So I can factorize out, and I say factorize out the cos x, then e to the power of sine x. Meaning inside here I'll remain with the cos squared x for this one here, then subtract. I took this one and this one out, okay? So there is a negative here and a negative, so it will be a plus. So inside there, I have plus 2 sine of x. So down here, I have the cosine of power 4 of x. Now this one can reduce this by 1. So meaning I'm going to have e to the power of sine of x into the cosine squared of x plus 2 sine of x. Then we divide by the cosine cubed of x. Then from there, I can cross multiply, okay? Now, when we cross multiply, of course, that one will go. That means we are having e to the power of sine x into the cosine squared of x plus 2 sine of x, which is equal to 0. So you'll get each of these factors, you equate them to 0. Even this one here, the cos squared of x, then plus 2 sine of x will also be equal to 0. But there is no number you are going to power this with, and then you get a 0, okay? So that means that's why we don't have natural logarithm of a 0. So this is undefined, so we leave it out, okay? Undefined. Now here, since I'm seeing sine x here, I have to express cos squared x in terms of sine squared of x. This is 1 minus sine squared x. This is the Pythagorean identity in trigonometry. 1 minus sine squared x, then plus 2 sine of x is equal to 0. I can deal with this one when the coefficient of sine squared is a positive. So that means I can take everything this other side. So I will have here sine squared of x, then minus the 2 sine of x, then minus 1, then this one will be equal to 0. We know you know how to use a calculator, okay? But please show the examiner that you have solved the quadratic equation, because they always say that attempt to solve the quadratic equation, there is a mark there. So sine of x here, because this is a quadratic in sine x, is going to be equal to minus b plus or minus to the root of b squared minus 4ac out of 2 of a. Okay, then from here we can get 2, then plus or minus. Inside here you have 2 squared, that is a 4, then plus a 4, that is 8. Okay, that is 8. So root of 8 is actually the same as root of 4 times root of 2. So this is 2 root 2. So I can write this as a 2 root of 2. 2 root 2, then divide by 2. Automatically the 2 will cancel all of those and it becomes 1 plus or minus root of 2. Now, this means that x can be equivalent to the arcsine of 1 minus root of 2, or x can be equivalent to the arcsine of 1 plus root of 2. But sine does not exceed 1. Sine is always ranging from negative 1, okay, to 1. So it cannot exceed, because this is this one here is 1.41 and the rest. So if you add 1, that one is going to give you 2 points. It's already beyond 1. So this one will be undefined. Okay, so we shall not take it into account. So how about this one here? What do we get? The arcsine. Now, since we were given, is the domain in degrees or in radians? The domain is in radians. So that means your calculator must be in radians. Okay, so mine here is in degrees, so I have to change it to radians. You press shift, then mod. Radians is 4, and then we press shift, then sine. We have 1 minus the square root of 2. Then we close the brackets. We get our answer as a negative. So it's a negative answer. That means we are supposed to pick angles from the quadrants where sine is negative. And I always use this circle here. Okay, so we have A, S, T, C. So I'm supposed to pick from these two quadrants. Okay, this is 0. Then here you have pi over 2. This is pi, then 3 pi over 2. If you move clockwise, okay, I mean anti-clockwise, this is 2 pi. So if we put these angles here, this is, let's say, theta, this is theta, theta, theta. So I'm moving to where sine is negative. It has to be here. I move like this up to here, and then I also move up to here. You see? So to get an angle here in the third quadrant, it is going to be pi plus theta. You see that? Because there is this pi here, and then there is this theta that we are adding on. Then here it will be 2 pi minus the theta. So you ignore that negative, which is the one that you have gotten in the calculator, but then you just say your x here is going to be equal to, in the third quadrant where sine is negative, it will be pi, then plus that angle you have gotten, but take it as a positive. Just ignore the negative. The negative just tells you where the sign is negative. So plus the 0.427, and then the other one is 2 pi, then minus that acute angle 0.427. So when we subtract them, what do we get? Pi minus, plus 0.427. That is that, but I'm going to write the answer to 3 significant figures. Okay, so 3.57. 3.57. These ones are in radians. Okay, that is one answer. Then the next one is here. X is equal to what? 2 pi, then plus, okay, it is a minus, so minus 0.427. This one gives me 5.86 to 3 significant figures. 5.86 also to 3 significant figures. So that is that. So this has been the first part of this paper. Thank you so much for watching. May God bless you. If you find the videos very helpful, kindly like, share, and even subscribe. See you in the next videos.